Question 1. What is the primary benefit of adopting a well-defined resource group deployment model in a complex cloud environment? Option A. To ensure all resources are deployed in the same geographical region for optimal performance. Option B. To enable the nesting of resource groups for granular hierarchical management. Option C. To facilitate efficient management, governance, access control, and cost tracking by logically structuring resources. Option D. To automatically encrypt all data stored within the resource group. The correct answer is to facilitate efficient management, governance, access control, and cost tracking by logically structuring resources. Here's the explanation. Effective resource group deployment models are crucial for maintaining clarity, enforcing security, streamlining automation, and ensuring scalability in complex cloud environments by aligning cloud resource organization with business requirements and operational best practices. Question 2. A development team uses a web app dev-rg resource group for their development environment. They have completed their work and want to completely decommission all associated resources, including VMs, databases, and storage. Which action, when applied to the web app dev-rg, will achieve this most efficiently? Option A. Move all resources to a decommissioned-rg and delete them individually. Option B. Apply a cannot delete lock to the resource group. Option C. Delete the web app-dev-rg resource group. Option D. Change the location of the resource group to none. The correct answer is delete the web app dev-rg resource group. Here's the explanation. Deleting a resource group typically deletes all resources contained within it, making it an efficient way to decommission an entire environment or application solution and preventing orphaned resources. Question 3. In the Azure management hierarchy, how do resource groups relate to subscriptions and management groups? Option A. Resource groups contain subscriptions, which contain management groups. Option B. Management groups contain resource groups, which contain subscriptions. Option C. Resource groups are nested within other resource groups, which are in subscriptions. Option D. Management groups contain subscriptions, and subscriptions contain resource groups. The correct answer is management groups contain subscriptions, and subscriptions contain resource groups. Here's the explanation. The Azure hierarchy is structured as management groups at the top, containing subscriptions, which in turn contain resource groups, and finally, resource groups contain individual resources. Question 4. What is the fundamental nature of Azure Resource Manager, ARM, templates? Option A. They are imperative scripts that define a sequence of commands to provision Azure resources. Option B. They are declarative JSON files that describe the desired state of Azure infrastructure. Option C. They are binary files used for compiling Azure applications. Option D. They are graphical tools for dragging and dropping Azure resources. The correct answer is, quote, they are declarative JSON files that describe the desired state of Azure infrastructure. Here's the explanation. ARM templates are a declarative infrastructure as code, IAC, solution. You define what times you want your infrastructure to look like, and Azure Resource Manager handles the steps to achieve that desired state. Question 5. Which section of an ARM template allows you to customize deployments without modifying the template itself by providing values at deployment time? Option A. Variables. Option B. Resources. Option C. Parameters. Option D. Outputs. The correct answer is parameters. Here's the explanation. Parameters are input values that can be provided during deployment, allowing for template reuse and customization without altering the template's core JSON structure. Variables are defined within the template and cannot be changed at deployment time. Question 6. When deploying an ARM template, which deployment mode will delete any resources in the target resource group that are not defined in the template? Option A, incremental. Option B, complete. Option C, validate. Option D, preview. The correct answer is complete. Here's the explanation. The complete deployment mode ensures that the resource group exactly matches the resources defined in the template. Any resources present in the resource group but not in the template will be deleted. Incremental mode, the default, only adds or updates resources defined in the template and leaves others untouched. Question 7. What is the primary role of Bicep in the Azure ecosystem? Option A, to provide an imperative scripting language for managing Azure resources. Option B, to act as a domain-specific language, DSL, for declaratively deploying Azure resources, simplifying ARM-JSON. Option C, to configure applications and operating systems within virtual machines. Option D, to manage state files for multi-cloud deployments across different providers. The correct answer is to act as a domain-specific language, DSL, for declaratively deploying Azure resources, simplifying ARM-JSON. Here's the explanation. Bicep is a DSL designed by Microsoft to simplify the authoring experience for infrastructure as code, IAC, within Azure by providing a more concise and readable syntax than raw ARM-JSON, which it compiles into. Question 8. Which Bicep component is primarily used to promote reusability and modularity by encapsulating a set of related resources into a separate, callable file? Option A, parameters. Option B, variables. Option C, outputs. Option D, modules. The correct answer is modules. Here's the explanation. Modules in Bicep allow you to break down complex deployments into smaller, reusable, and focused Bicep templates, enhancing modularity and maintainability across different projects. Question 9. An Azure administrator has finished authoring a Bicep file, ..bicep, for a new infrastructure deployment. What is the necessary step that occurs before Azure Resource Manager can process this definition? Option A, the Bicep file is directly executed by the Azure CLI on the target resource group. Option B, the Bicep file is transpiled into an ARM-JSON template. Option C, the Bicep file is converted into PowerShell scripts for deployment. Option D, the Bicep file is uploaded to Azure Storage for staging. The correct answer is the Bicep file is transpiled into an ARM-JSON template. Here's the explanation. Bicep files are not deployed directly. They must first be compiled, transpiled, into a standard ARM-JSON template, which is the format that Azure Resource Manager understands and processes for deployment. Thanks for watching. Please subscribe to my channel.